Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura and I'm joined by Jasmine and Antonia to talk about whether carbon capture is being used in industry right now and debate whether the captured CO2 should be used or stored. And we're actually joined by a special audience of students from the Engineering Development Trust's Roots to STEM course who will be asking us questions via a chat function, so we'll try and answer those throughout the episode. Now, we've talked about various aspects of carbon dioxide in several episodes over the years. So we've talked about whether it's a good idea to burn trees, which capture carbon, and why we're so slow at developing ways of capturing it and making human-made technology. And we've also talked about a cool new startup that's using some of this tech to make fuels using electricity. So this time we're focusing on industrial applications. And Jasmine, I know this is part of your area of expertise, so what fascinates you about it?
Carbon capture is actually something that's been used by industries since the 90s. So the oil and gas in the sector has been using carbon capture and storage since the 90s, firstly in Norway. Other things that I find interesting about it is that for decarbonising, for certain sectors, they need carbon capture and storage if they want to meet any kind of net zero target. It's just because stuff like cement, the CO2 is not actually mostly from any fossil fuel burnt. It's actually from when the limestone breaks down and releases a lot of CO2. So for cement and some of the other things, there's no way of decarbonising it without carbon capture.
So I didn't know that there had been industrial uses of carbon capture since the 90s. So I did my PhD in one very small aspect of this in sort of 2010, 2013. And it was still very much a technology that was being developed for a whole range of different applications, recognising there was a need to stop sending it into the atmosphere.
I think because the use in Norway is slightly different. So in Norway, they really push for carbon capture because the Norwegian government introduced a carbon tax. So the CO2 that was being captured was actually CO2 that was in the natural gas that was being produced. It had a higher CO2 content than what was allowed. So they had to separate it out. Otherwise, they're going to be very heavily penalised by the Norwegian government.
It sounds kind of funny that there has to be a legal incentive to do it. There can't just be this moral, altruistic goal.
Yeah.
But Antonia, you've got an interest in this as well, but slightly different background. And this follows on from an episode with almost 2 years ago. There was a CO2 shortage. We were talking about why aren't we capturing more of it from the air and using it to do things?
I started hearing about carbon capture storage during my undergrad as a chemical engineering student. There's that interest from a climate change perspective, but also something that's talked about in chemical engineering. And when you're designing, say, a chemical plant, you want to make a certain product, but as a result, you might end up with waste product or byproducts. Naturally, you'd have to get rid of them and treat them somehow. For example, that case of the natural gas, we having to extract the CO2, you could either just throw away the CO2, but the Norwegian government had restrictions on that, or you can try and sell it on, make something useful out of it. And what people are saying is, even if we had, say, like biomass carbon capture storage, is it just that we store the carbon or is there a use for carbon? Something I'd been reading about is actually carbon dioxide has a lot of uses, which we discussed in that episode 2 years ago, in the food industry especially. There are other things such as making it into other more complex chemicals. So there's a lot of things that I think have an avenue for innovation and making better use of what we already have.
Yeah, and one of the things we were saying in that episode was that although we can capture it, it's actually quite energy intensive to do so. So it's far more economic to use it as like a byproduct from other processes where it's sort of separated out anyway. It's just a better way of doing it. Seems a bit of a shame in a way. So I like that you're saying that there needs to be some change, there needs to be some innovation to get people to do more with it.
There's a lot of chemistry that you can create. So there are lots of different chemicals that can be built off CO2, and it's about, bringing that from lab scale to real scales, like, on a manufacturing level where you can actually have enough to make it a viable supply chain for another business. So, there's a lot of steps even after you've discovered that you can use CO2 for that reason. You've got to build everything else, and I think we're still quite early on in that stage.
Yeah, and some questions coming in from the audience as well. So one is, why aren't more countries working in a similar way to Norway, trying to incentivize industries to not emit as much CO2? Does either one of you have any thoughts about why or are places doing it in a similar way to Norway and we're just not hearing about it as much?
Norway was a very interesting one because they were imposing a carbon tax in the 90s. There are other countries who are imposing carbon taxes, and obviously there is like the current emissions trading scheme that it's basically like a carbon tax. But like the main thing is just like the price of the carbon has to be high enough that it incentivizes companies to want to do more to actually go about reducing their emissions, because if it's not high enough, then the cost of emitting just ends up being cheaper than the cost of actually like doing stuff to actually reduce how much they're emitting into the atmosphere. So that's one of the main things in terms of like why there's not as many countries doing it or companies doing it. There is increasing interest and like just like political will in terms of encouraging carbon capture, because it's just been generally acknowledged that we're just too far into the climate change. We're too far into global warming climate change to like not have carbon capture. So we just really need to accelerate the rate that is being used, because it is being used at industrial scale, but currently only to very large emitting facilities. So like the refineries, cement plants, some thermal power plants. But it's mostly just to do with you need to make it a case for that so that businesses will find it like economically viable to want to decarbonize rather than to actually just pay a tax or a penalty for emitting CO2 into the atmosphere.
And I guess the next question from the audience also kind of follows on from that. It's about what could be done to make people more environmentally aware. And I think it sounds like you're saying, at least for companies, there's just no financial incentive to do things differently. And at the end of the day, it's all about making money, sadly. I think there can be a lot of consumer pressure, though, to make change.
Yeah, I would agree. Like, you could argue like the companies who do emit and who do like but use fossil fuels and emit CO2 and other greenhouse gas in the atmosphere, that they do have some kind of like moral reasoning or grounds to go about abating or reducing their greenhouse gas emissions, but at the same time, they're companies and they have a bottom line. So if they go bust, then they go bust, and another company will just like, then there'll just be like another company who like will like see that and just be like, okay, they made that mistake of having a very bad business plan, so we're just not going to do what they did. So yeah, it's quite complicated, because you need to like make it make it so that businesses can actually still grow and survive, even if they are having to like pay extra for all the additional technologies and changes needed to their facilities so that they can decarbonize.
I feel like this is touching on a lot of what we discussed in our episode about sustainability, Antonia.
Yeah.
We talked more about sustainable development.
And from my experience as a consultant to businesses trying to cut their greenhouse gas emissions, it's really difficult, because if you don't have unity, you could lose, say, to your competitor, as Jasmine said. But it's also, even if all of the UK agreed, let's put on a carbon tax, which we actually have got in place, it's just very small, it still impacts us, because we already have like high wages and higher health and safety standards than, say, other countries. So their, say, cost per unit of whatever product is going to be lower than another country. And so if you're just choosing the cheapest product, it might end up that we've taxed people in the UK too much that they lose to international competition. And then it starts becoming about economics, even though we're talking about climate change, which is scientifically proven to happening, and we see the effects in Europe right now with like heat waves and forest fires, a lot closer to home.
July's been the hottest month in recorded history, so climate change is real.
Yeah.
But clearly not in the UK where it's been raining.
Well, if it's been raining more than average, though.
Yeah, climate, not weather.
Yeah.
Another episode we've had about weather predictions and not being the same as climate.
Yeah, and getting a bit more difficult to predict because of the changing parameters. I feel like we should probably move back on to talking about carbon capture, though.
Yeah.
Jasmine, you mentioned there are lots of ways to capture carbon.
It's another reason why carbon capture in general isn't widely used, is because there's just lots of different ways you can capture carbon. I'm going to talk specifically about capturing carbon from combustion gases or flue gases. So in general, there are three different ways of capturing it. You can capture it post-combustion, so you separate out the CO2 from the actual flue gas. And there's also pre-combustion and oxy-combustion, where you make it so that when you burn your fossil fuel, you end up with a pure stream of CO2 rather than a mixture of CO2 and other gases. Currently, the most widely used one is the post-combustion, just because it's easier and it's the most mature technology. One that we could potentially see more in the future, which could have potentially really good applications for more of the smaller scale industries, called chemical looping. What you do is you use metals basically to separate out the oxygen from your ingoing air. So you end up with a pure oxygen that ends up reacting with your fuel in the combustion process. Because there's no other gases present, you end up with a pure stream of CO2. And what's interesting about chemical looping is that it's circular, so that you have your reaction of your metal, so things like iron or manganese. Your metal reacts with the air to separate out the oxygen. So that bonds with the metal in the oxidation process, and then your oxidized metal then gets sent into the chamber where you're going to be burning your fossil fuels. And because you only have the oxygen present, you end up with a pure stream of carbon dioxide. During that reaction, the metal then becomes free, and then that gets looped back into the first reaction. It's still in very early stages of development, but it has a lot of potential for being used on a variety of different scales. So not just like really big scale, but also on the smaller scale. And based on what's going on in terms of the research, it looks like it's one that could be very easy to retrofit, because that's going to be a really big factor in how industry and companies will develop and incorporate carbon capture into their processes, because you want something that doesn't dramatically change your facility. So it could be one that we see a lot more being used in industry.
For me, the question then is, if there are other technologies that are more difficult to retrofit, what are they and what's the difference? What makes them more challenging? Or is that a really difficult question to answer?
No, it's not. The main thing is to do with scale of how much CO2 you need removing. Chemical looping is an interesting one because you basically just need 2 reaction chambers, whereas for some others you need things like multiple heat exchangers, multiple reaction chambers, multiple like separation columns. For example, in the most commonly used method of carbon capture, which is post-combustion amine scrubbing, you separate out the CO2 from the combustion gas using a liquid amine, but you then need to separate out the CO2 from that liquid amine, so it has to go through a series of different like heating and cooling processes. So you actually end up with like lots of different equipment that you need to add onto your facility, which can be tricky if you're quite limited in the space that you have available. So that's why it's mostly being used by the larger facilities, because they generally have more space, or they're in the middle of nowhere. But for things like a small refinery or a smallish... trying to think of other things that emit CO2 that are smaller than a cement plant. Antonia, what's smaller than a cement plant but also emits CO2?
Beer making places. Bread making places.
Yes.
I was going to say a very, very large fermentation plant.
Yeah, fermentation plant, yeah. Like they could also use chemical looping as well.
The biggest challenge I found is it's making a change on site which isn't insignificant, and if you're doing something else that your main thing is, or the only reason why you're emitting CO2 is because you combust a lot of fuel, you might not necessarily have the expertise to run a amine scrubbing plant, and so it's that extra difficulty to someone who might just, I don't know, be like a paper mill or something.
Oh, okay.
Yeah, that is true.
When we've talked about this before, I've always thought about it in the context of these like big chemical plants. So my PhD was on membranes that could be used in post-combustion, as you said, Jasmine, and you had all those different gases in there that would compete with absorbing into the same membrane or filtering through the membrane. So that's what I tend to think of. I don't tend to think about those other smaller, less, I guess, technical plants, or technical in that way.
Or imagine all those microbreweries with all the craft beer. They're only as big as like a garage, or like the archway underneath some rail in Manchester. You know, they're not gonna get a whole nother chemical plant, basically.
It's true. Are you a connoisseur of craft beers, Antonio? Do you go around sampling them all the microbrews in Manchester?
Not yet, but could be a bit of fun. Just go in and be like, hey, have you considered trying to capture your CO2? And they probably go, no.
Then you can tell them about chemical looping, or you can introduce into the concept of using a membrane, because a membrane is another technology that you could use, but it's just like very, very low in terms of technology readiness level, so no one's really looking into it.
You just need the right size filter, isn't it? It's like a sieve.
Yeah, yeah.
I was going to say it was 10 years ago my PhD was on membranes, and it sounds like they've not really moved on since then.
No, they've really not. Basically, what happened was they were like, yeah, amine scrubbing works great, we'll go with this.
Yeah, there you go. One winning technology, and that's it. All the others can just disappear for these smaller, but I guess quite significant industries. Antonio, I don't know if you happen to have any stats from your consultancy on the smaller producers that are significant, because we hear about steels and cements and energy quite a lot.
Well, that's the really interesting thing. So, like, Jasmine mentioned the emissions trading scheme, and the threshold for those is a lot bigger than what you'd think. I don't know many companies, and that's because of the sort of size of companies that I work with. But, like, and imagine a little housing estate. They're kind of that big. They still emit a significant amount of carbon dioxide, but wouldn't fall under, like, emissions trading scheme. So, in a sense, the only way to incentivize them to capture CO2 would be a technology that is easy enough for them to use, cost effective, because they're not falling under those kind of carbon penalties, or there is more sort of environmental pressure, which I have to say there is with other companies committing to certain targets of carbon emissions. It means that everyone they're working with also has to commit to those. Otherwise, there's no point saying, oh yeah, well, I do very little, but the thing that I purchase, that has high carbon emissions. So, I don't want everyone to come away from this talk that we don't do a lot. There is a lot more we can be doing, but there is something that is happening as well. But yeah, in terms of size, I want to say, like, it's all the other sectors. They still make the vast majority of greenhouse gas emissions. It's not just steel and cement, but they're the most concentrated places where you can capture CO2, whereas everything else is just anything that burns fuel.
Yeah, pretty much.
Yeah, and I guess that's part of the government incentive to switch to electric cars rather than ones that run on petrol and diesel. I'm still not 100% convinced by electric cars, to be honest. Well, that's a different episode again.
Well, by 2030, you won't be able to buy a new diesel or petrol car.
Not a new one. I know I've never bought a new car, though. I've always bought second-hand. I haven't driven a car in 10 years, so...
Well, to tackle global warming from refrigerants, they phase out selling new refrigerant, but this is different. Obviously, a car is made up of multiple parts, so you just need to still be able to find all those parts of the car, which might stick around for a bit longer. I mean, people still make vintage cars work, so you just be like living on eBay, just like right, or maybe you'll 3D print it.
Yeah.
Maybe. I do like my vintage stuff and using things secondhand as well. That is a way of reducing your carbon footprint by just using things for longer.
Yeah.
Yeah, it's true.
But we're getting distracted from the carbon capture questions again.
Yes.
Because you can't apply carbon capture to combustion engine cars.
I guess you could, but the energy penalty would probably be so high that then your car wouldn't go anywhere because all the energy would be going into capturing the carbon. So you're just creating a perpetual carbon capture machine.
Yeah, and also, like, how big is your car? Like, what does your exhaust look like?
You tell me, Jasmine, you know the technology.
It's just why, to decarbonise transport, you kind of have to, like, look at biofuels, electric or hydrogen, because carbon capture just really doesn't work.
Imagine, like, even though it's not a battery car, it's a combustion car, and then you have something that's attached on, like a little wagon. Just be a train. In which case, we should just take the train.
Yeah. That's what I tend to do, even though I don't live in the best place for it. But I'd much prefer public transport. I'm waiting for a public transport revolution, so no one needs to own a private vehicle. There's just something available that turns up when you need it and takes other people on that same journey.
I was driving on a motorway and I thought, what if this motorway was on rails, you know?
How would that be helpful?
Because Because there's loads of people, there's some people who are like too slow, and then there's some people who are trying to exceed the speed limit. So like if we were just on a rail, there'd be none of that concern about, is this person trying to overtake me? Are they going to crash into me? About it.
So are you saying, I can't work out if you're saying that once you're on the tracks, then it then takes over the speed that you're traveling as well, so you have no control over the speed. Is that what you're saying?
Yeah.
Yeah, because that's not what it sounded like, and it sounded like we were just all
Oh.
stuck behind this 30-mile-an-hour car.
Oh God, no, 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 no. Why would I want that? Anyway,
Yeah, anyway, back to carbon
Yes.
capture.
Yeah.
'Cause
Yes, there is a question in the chat from our very sensible audience. After being captured, will the carbon be stored, and how environmentally friendly is the storage system?
So that's a really good question. So right now, the majority will be stored is the main plan. As Antonia said earlier, you can use it in making different products. So like carbonated drinks is a really big market for using CO2. You can also use it as a feedstock to make certain chemicals. So things like methanol and like other basic chemicals, you can use CO2 to make them. You have to change your manufacturing process. You can also like use it in greenhouses to enhance productivity because photosynthesis. But the majority of CO2 is planned to be stored in geological storage facilities. And as far as the science indicates, it is perfectly safe. There's been no cases, as far as I'm aware, where they've detected CO2 that's been leaking from any of these facilities or from these pipelines. But having said that, the scale of carbon storage is still very small right now. We're using depleted oil and gas fields to store the carbon, so it's really important that we check that everything's A-OK in these different facilities, as well as also in the pipelines.
Other types of storage apart from in geological facilities, like in the ocean, that's an idea that people have suggested. I don't know if that is the right way. I feel like we're sort of changing the carbon cycle.
The thing is, the ocean is already a really big sink, and when I say sink, I mean method or place that removes carbon from the atmosphere, so it's part of the carbon cycle. Right now, the ocean's kind of at capacity in terms of absorbing carbon because we've been pumping it too much into the atmosphere. When CO2 is in the ocean, it makes it more acidic. But if you make it more alkali, then you increase the ocean's ability to absorb CO2. So there are I wouldn't say there's plans, but it's been suggested that you could have projects where you basically make the ocean more alkali to make it better at absorbing more CO2. But it's quite controversial because then you're need to think about what impact it would have to local marine wildlife and habitats, and also it's just generally controversial because we're already putting enough junk into the ocean.
So basically the only places to store it are potentially the ocean. That's a terrible idea, or more likely underground. But then if you can't use it, then are you really going to incentivize people to just create waste effectively when they could previously just pump it into the atmosphere and not have any cost with it? I guess the other thing to do is to find some use for it.
So I think in the future there is going to be a growing market for using carbon because there's this concept called the circular carbon economy. So using carbon that's been captured from different industrial processes. But right now, natural gas is a really big feedstock used in making a lot of basic chemicals like ammonia and methanol. As we move away from fossil fuel based raw materials, there will be a growing market for okay, how do we still produce all the ammonia that we need to make all the fertilizer that we need to make food if we're not using natural gas? The main alternative way would be to use hydrogen, and then you'd also use nitrogen from the air. So that would be a direct replacement for ammonia. But for other things like the hydrocarbon-based chemicals, you still need a carbon source, and CO2 is probably going to be the source that we use rather than other methods.
I see this captured CO2 is replacing the fossil fuels that we've dug up to use as our carbon sources, and the ones that we dig up, they come in various chain lengths. If people remember crude oil distillation, the smallest lengths are actually most useful because you can tailor exactly what chemical you want.
Yeah.
CO2, some people calling it a C1 source because it's got one carbon atom, and so then it's much more versatile. And I've seen some very complicated chemical journal articles which say, here are all the possible useful reactions it can do. There are a lot. I think Jasmine didn't mention polymers.
Oh yeah, you can also make polymers from it.
In general, knowing that you can have methane or methanol, we call it chemical building blocks, and you can basically make a long chain of those.
Yeah.
And you have plastic. and some of these plastics, very useful. I think on another episode we talked about plastics.
Everything is linked, pretty much.
Yes.
I feel like that answers one of the questions from our audience about if it's not beneficial economically for companies to capture carbon, then how could you make it more appealing? The answer is find a use for it. Sell it to someone else who can make something with it.
Yeah, also another reference to our e-fuel episode, which is where some of those captured CO2 could go.
And I guess kind of related to that, not so much about businesses, but there's a question in the chat from the audience about, is there anything similar to carbon capture that could be put in people's homes or made more widely available to use? So I guess the idea here is that most of us have gas-fired boilers for heating and hot water, and they obviously emit CO2 and other greenhouse gases potentially. So could I have a mini carbon capture plant and then sell the product to someone?
For houses, probably answer is probably you could in theory. In terms of like practicality and economics, probably no.
Yeah.
Would probably be better off to fuel switch, unfortunately.
What if I got together with my neighbours and we all sort of combined to have the gas from our boilers funneled together and put into a production plant somewhere in my local community? Would that work?
I love the idea.
Do you live near a facility that could use the CO2?
Potentially, yeah, there might be a new nuclear reactor near me. That might be CO2 cooled.
I think that's a very specific case, and I think that's the thing about engineering solutions is often you are trying to select the perfect, not the perfect criteria, but the criteria where it could work. And so, I love the idea of like community energy projects because a bigger plant is generally more efficient than lots of little individual ones because you can even out sort of saying someone doesn't ever shower in the middle of the day, but someone else might do, then you can sort of even it out and the boilers don't have to work as hard. But still.
Yeah, but Laura, if you do want to advocate for like carbon capture for houses, write to your local MP because they could really like try to push it in Parliament because right now Parliament and the government are really going more towards like heat pumps for houses to like replace gas to a certain extent.
And this is the thing, a heat pump for my old 1940s really leaky house just wouldn't make sense. So there has to be something else.
Yeah.
So which I guess is where you were saying hydrogen would come in. So I just replaced the boiler to one that was hydrogen ready and wait for that to come online. But that's quite a long way as well. A long way away.
So like hydrogen has had so many hurdles.
The way you say it feels like you personally have felt those hurdles.
I personally have to a certain extent because there was supposed to be a test village where they were supposed to be like the first village that was 100% hydrogen, but then the local residents were like, no, we don't want this. So yeah, hydrogen does have potential. It's just there's just a lot of hurdles that it's facing in terms of demonstrating that it is perfectly safe to use domestically. I'm not trying to blame things like the most recent Knives Out movie, but it doesn't do hydrogen any favours.
I remember watching that film and it just kind of washed over me.
I don't remember that part of Knives Out.
It was Knives Out 2, the second one.
Yeah, I've watched that as well and I do not remember when that happened. I know it was something related to energy. I just ignored it.
Fair enough. Question from our audience to bring us back on track again. Going back to something we said quite a while ago now. Which method is more eco-friendly, pre-combustion capture or post-combustion capture?
Eco-friendly. Unfortunately, because the post-combustion is the most widely used and the other two aren't really that widely used, it's difficult to actually compare on a even and fair basis because each one will have different waste products that are produced and they will also consume different types of chemicals which will all have different types of toxicity impact, so it's quite difficult to compare directly.
See, that kind of suggests to me that it's possible for carbon capture to be worse for the environment potentially.
Oh yeah, for sure, yeah.
Because it's not just about the emissions at the factory, it's where all your other materials come from.
Oh yeah, for sure.
And then what you do with them afterwards.
Yeah, when I was doing my PhD, there was like another group who were looking at alternative chemicals that you can use in post-combustion carbon capture. They were like comparing these green chemicals and they weren't always better than the more conventional one that's being used called monoethylene glycine, which I think that's what it's called, MEA.
As long as you remember the acronym, that's all you need. Everyone knows what the acronym means.
MEA, yeah.
So I think one thing we were discussing was about carbon credits, and it was about how you identify how much CO2 a company is producing and whether you can actually be carbon negative. And I find any company that says they're carbon negative, I really wonder what they mean by that, because I don't know the calculations in the industry well enough to know what that final conclusion is based on.
With carbon negative, you need really accurate carbon accounting for one, both in terms of how much you're emitting, but also how much you're planning to remove. Was it Brewdog who were claiming to be the world's first carbon negative beer company? Because they were going to plant a load of trees in Scotland. So they'd have lots of credits from the amount of CO2 that would be removed from all these trees. There's a lot of factors that go into how much CO2 a tree is going to remove, because you need to figure out how long is this tree going to live? How many are going to survive to maturity? And also the amount of CO2 that gets removed. It varies depending on weather conditions, as well as just general health of the tree. Any kind of carbon accounting or carbon credits using any of these agroforestry projects, there's really high uncertainty on whether or not they're actually going to be net negative.
Wow. See, I like the idea of planting trees because it sounds like a good thing for the environment. It creates habitats and all sorts. But I can also see why there would be all that variability. So you're essentially saying that the best way to do it is to engineer it using known technologies like capture using amines.
You wouldn't have necessarily say it's the best way, but it's the most accurate way. So if you engineer a facility that you know is going to remove 1 ton of CO2, it's most definitely going to remove that 1 ton of CO2. Whereas if you want to achieve that through trees, it's a lot more uncertain.
There could be uses for those trees. I know one of the previous episodes we've had about building skyscrapers. The construction industry is looking to use wood as a replacement for steel because steel emits CO2 and trees are more renewable. But of course, you have to wait for your trees to grow. So it's got to be a limit there as well.
Yeah.
I'd agree with Jasmine, but forestry and afforestry, replanting trees where we deforest, is all really important for various environmental things. So it's just whether or not you should count that as a credit and start using that in accounting, especially if it's not happened yet.
Yeah. I would say that if you were to plant trees, I would put other benefits above using it for carbon credits. So habitat benefits or just general improvements to nature benefits. Also air quality benefits.
So a lot more wins than just sucking CO2 out of the air, which you would do with your engineered method.
Yeah.
We have a couple more questions in the chat. They're not directly related to CO2 capture, but I think they're quite interesting.
It's fine.
So the first one is about whether it's feasible to use renewable energy in countries that have a lot of it, like the geothermal in Norway, and we have a fair amount of production of electricity from wind in the UK. How easy is it to distribute that to other countries that don't have that sort of capability? And I guess for one that I'm aware of would be India, because I know India is really reliant on coal at the minute, still probably will be for quite a long time.
The thing with that is you would need to extend and have better connectivity in electricity grids. So countries are connected and not so much share electricity. So the UK gets electricity from France. So we have the subsea interconnector that connects us. And other countries in Europe, they're also connected through their electricity grids. There is potential you'd have to have more connectivity in the different countries that need the green electricity.
I think we've started connecting to Denmark's grid as well in the UK, and we also have an interconnector to the Netherlands and to Ireland. The challenge becomes the materials and the technology to be able to lay down these cables to connect countries. Trying to get it to other parts of the world, I think we might have to use less physical means, but use more economic means or sharing knowledge of the experience we've got, and they'll have to adapt it to their own environment because the climates here are quite different.
So there'd be different engineering considerations depending on which part of the world you're in, because different environments.
Yeah.
And I guess that kind of touched on the second part of the question, which is all about why can't more countries use nuclear power? Because fission-based nuclear reactors are one of the safest places to work, according to our very knowledgeable audience participants, and they're way more efficient than fossil fuels. Very true.
I feel like you should answer this question, Laura.
Well, I think it goes back to what you were saying. Partly it's about materials, but also it's about training people. As you say, there's a need to share all that knowledge and upskill people. And the nations that have nuclear power are sort of going through a bit of a renaissance themselves. In the UK, we had a huge boom in creating nuclear power stations in the sort of 60s, 70s, 80s, and then that tailed off for political reasons.
And also because we discovered we had lots of natural gas in the North Sea.
Yes.
So it wasn't really needed, yeah. Whereas now that is changing again, and we're saying, yes, we really need nuclear to help with the whole climate change emission of CO2. So let's go that way. As for fusion, There's a saying in the nuclear industry that fusion will always be 30 years away. It's still 30 years away.
I thought it was 50 years away.
Oh, maybe. Well, it's come down a little bit then. There you go. It's creeping closer.
It's gone down.
It just feels a little bit more tangible these days.
Yeah, there's definitely a lot of research in the area, so I'm sure they will get there, but it is still there's an awful lot of research left to do still. It's nowhere near as mature.
I find it interesting that when it comes to like public attitudes and acceptance for like, okay, so I'm probably going to get this wrong, but is it fission? That's the one that's used mostly right now, and fusion's the other one, right? So like fission.
I do as well
sorry,
a lot
I
of
get
the time.
confused between the two. Yeah. So with fission, there's like a lot of like anxiety about it because we've had quite a few nuclear disasters related to fission reactors, but with fusion, like there tends to be generally like more public acceptance because one, you don't get any nuclear waste associated with
You don't get as much nuclear
fission.
waste, for sure.
You don't get as much because it's quite interesting because like in Germany they decommissioned all of their nuclear power plants following the Fukushima incident because of concerns, even though Germany's probably not going to have a tsunami anytime soon or experience a tsunami. But yeah, it's just like there was a lot of concerns following Fukushima, and then Germany decided, we'll just decommission all of our nuclear power plants, but that resulted in them using more coal because they still need electricity.
Yeah, and the UK is currently, it was about 20% of our energy mix was nuclear. It's gone down a little bit because a few plants have closed, so there is a need to have more plants to fill that gap.
But I suppose that's part of it, is that carbon capture storage isn't a technology in isolation. It's got to be, what are the alternatives to not capturing the carbon, or what benefits are there if we do capture the carbon?
To sort of follow on from the talk about nuclear, there is definitely a need to decarbonise the electricity production, and nuclear is a good way of doing that. But there can also be uses of the CO2 that are captured from gas-fired power stations. I think I'm advocating just keep using gas, but that's not necessarily what I'm saying.
Yeah, especially with the high gas prices, please don't.
But for some of those industries that are more difficult to decarbonise, like steel production and cement manufacture and beer making.
Yeah, you kind of need carbon capture because the alternative is you make a completely different product.
Yeah, so I guess that's probably quite a good place to sum up. There's a need to decarbonise electricity. There are certain industries that are much more difficult to decarbonise, and that's where carbon capture and using it rather than storage would probably come in. And that generates a whole other economy of creating other products that require carbon in them in some way. Thank you to our audience.
Yeah, thanks everyone.
Thank you all for listening, and tune in for another episode soon. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.